Let's begin. Exercise 5D. So today's lesson, still relatively straightforward. You would have learnt how to collect like terms in the last exercise on 5C. 5D is also still collecting like terms, except this time we're doing with multiplication and division. Let's have a look at the first one here. Let's recap. With numbers, we've learnt that we are too lazy to do 5 times 5 times 5 times 5. There is a shorter way of writing this using index or indices. What is 5 times 5 times 5 simplified to? Hands up if you know. Yes, Belinda? 4. Very good. You've got 1, 2, 3, 4 of them. And if you're timesing themselves by 5, so repeated multiplication, we then rewrite it as 5 to the 4. Which is better than, say, for example, if I gave you 5 to the 99, you don't want to be sitting there writing 5 times 5 times 5 99 times. That's the benefit of it, right? So that's called indices, and that's when you have repeated multiplication. So that means, if I zoom out a bit, that means even for letters are numbers. We just don't know what the number is. So then A times A times A times A should then be written as, what's that go? A to the power 4, very good. So A to the power 4 is the shorter way of writing A times A times A times A, right? So again, same idea. If I wrote A to the power of 99, you don't want to be sitting there writing A times A times A 99 times. So that's the benefit of that notation. The problem is that it's not this that is confusing. Students are pretty good at that. The problem is when I mix the two now. So common misconception, which is the one that I was testing Attila just now. 5 plus 5 plus 5 plus 5, this is one of the first things you learn when you first started primary school. Okay, you learned how to add, then you went backwards, so you learned to subtract. Then we realized that actually we do addition quite a bit. Sometimes we add it repeatedly, right? So 5 plus 5 plus 5 plus 5, yes, I know the answer is 20, but there's a shorter way of writing it. What's the shorter way of writing 5 plus 5 plus 5 plus 5? So repeated addition. What is that? Yes, Willow. 5 times 4. Very good. So we normally say 4 groups of 5. That's what that means. 4 groups of 5. Because I've got 1, 2, 3, 4. That's 4 groups of 5s. Yeah, so that's 1 group of 5. That's 1 group of 5. That's 1 group of 5. So you add them all together. Which saves us time from doing something like if I wrote 120 times 5. You don't want to be writing 5 plus 5 plus 5 120 times. Okay, so that was the benefit of learning multiplication. But then that links into, 16. That links into, if you can do multiplication as a short form addition, that means repeated multiplication has to have a shorter way as well. Okay, so then where's the confusion? The confusion is this. When I give students A times A times A times A, at the moment, you remember as A to the power 4. But by the time you start doing 5C and 5D, see, A plus A plus A plus A, when I taught you this, you guys didn't get confused. I said, how many A's are there? You would say there are 4 A's, yes. So you got 4 of those A's. You had no confusion there. And I kind of linked it to like apples and bananas. So there's like 1 apple plus another apple plus another apple plus another apple. There are 4 apples in total, right? So this was not a problem. And remember, 4 next to A actually means 4 times A. And the reason why it's times is because, same theory, 4 groups of 5, this is 4 groups of A. So same thing. The only difference between the two is one has a number, one has a letter. Yeah, so that's generally where the conception is. So a lot of students think these two are equal. So when I put in a test, after you do 5D, there is a large number of you, usually about maybe 40% of you, will answer, if I gave you A times A times A times A, you will write 4A. Okay, that's very common, so common. So I want you to look at these notes and make a note somewhere to know there is a difference between the two. One is repeated addition, which back in primary school we know is times tables. And then in year 7, repeated multiplication is index laws. Okay, so that's different. So that's indices there. Misconception or mistake starts to happen when I start adding numbers in. Okay, so right now it's just letters. But once I mix letters and numbers, that's where you have to remember timesing is index, Adding is multiplication. Yeah? So let's go back. Let's have a look at this one now. So, see the difference between the two? One is times, one's addition. Very different answer. This is what you did last session. This is what you're doing this session. So last session, let's go back to this one and revise. Which one are my like terms? There are two terms that are like. Which two are the same? All types. Yes, fits right. A's and B's. This is my group A's. They're all A's, so I can add them together. This is my second group, B's. I can add the B's together, but I can't mix the two. Apples and bananas are different. So if I ask you now, what's the simplified version of this expression? A plus A plus A plus A plus B plus B can be simplified to what, Josh?
A to the power 4 plus B to the power 2.
Ooh. Mistake. See that? When it's repeated addition, it becomes times. You see what I mean? 40%. I'm not wrong on that. 40%. So the answer, instead of A to the power 4, it should be, for this one, should be 4 apples, so 4 A's, plus 2 B's. Okay, so in that case there, this is different. Very different. You can't add these two together. One's apples, one's bananas, and you keep it as it is. This is last exercise. This is 5C. Yeah? Versus the one that I'm trying to teach you today, which is the main confusion. You have to ask yourself, is it add or is it times? If you get that clear in your head, you're less likely to make this mistake. So now, this is the question when you're timesing. So we know A times A times A times A 4 times is not 4A. This one is A to the power 4. This one you got to be careful. So this can be written as A to the power 4. The times symbol is still here. And then what's B times B? Let's go with you, Chen. B to the power 2. Very good. These two are not the same, so you can't group them together. Right? So it's just A to the power 4 times B to the power 2. But remember, as mathematicians, we're too lazy to write the times. So instead, this is how we write our answer. A to the power 4, B squared. Okay, so every time you have a letter next to a number or a letter next to a letter, in between is a times symbol. We're just too lazy to write it. Okay, because we actually use times and addition a lot more often than other things we do. We use it more than subtraction. We use it more than square rooting or cube rooting. This is the two really main options or operations that we do. Times and add. That's why we learnt shortcuts to making it shorter. Okay, so that we can do big calculations. So here, A to the power 4, B squared is different to 4A plus 2B. Can you see one has addition in it, and that one there's a hidden multiplication between the two. That's the difference. This is today's exercise. That's last sessions. Okay, so last week's. Let's do another one. Explain the difference between multiplication and addition. So I want you to write just a note here. Repeated multiplication leads to, so draw an arrow, to powers. Repeated addition leads to multiplication. Okay, so it is easy to mix the two, but that's why you just have to look for the signs. Okay, so times, usually it's hidden. But if you see adds, any adds separates the term, that's when you collect it by adding, subtracting. All right, let's do an example together. Let's have a look at the bottom. So again, I'm doing a contrast between 5C and 5D. Yeah, so you can see the difference between the two. Here we go. Let's have a look at the next two examples. Let's do the C one. Okay, you did this last session. So let's simplify this one. How many terms are there in this expression? Can I please have, let's go with Xavier. How many terms do you see? 3. Very good. Separated by a plus or minus sign. So that's 1, 2, 3. Now out of those 3, do I have any like terms? Any like terms, Jacob? No. Because there are no like terms, you can't add them. Yeah, so that has an A. This has an A, but it has an A and a B. So 1A, 1B. So they're different groups. This one is just a B. This one has a B, but this also has an A as well. So this group is different to that group. This group is different to that group. Can't do anything. So if I ask you to simplify that, the answer is just 2a plus 3ab plus 4b. Can't do anything about it. Okay? Nothing in common. Different to today's lesson. So today's lesson, we're now looking at this now. I'm going to get you to break it all apart. What does 2a mean again? What's in between 2 and the a? What's happening? Yes, Carissa? 2 times a. So if you split it out, I want you to write it as 2 times a. So notice this is a times symbol, so that's times again. What do you think 3ab means? What does 3ab mean? Very good. Okay, every time you write it next to each other, it means times. We're just too lazy to write it. So if you break it apart, the 3 next to an a means 3 times a, and a next to a b means a times b. So if you write it out, it's 3 times a times b. And then, notice again, you've got another times. Last one. 4b means what? What does 4b mean, Attila?
4b.
Yeah.
Like 4.
What's in between 4 and b?
4 times b.
4 times b. Very good. Now the key part is, can you see the difference between the two? This one has addition. Yes, it has a mix of times in between, but they're groups, separated. There is no separation for that. That's still technically one term. It's not 3 terms. It's actually one term because it's not separated by a plus or minus sign. That's just a very big one term. Okay? So that means, remember, multiplication, you can swap the order. Whether you do 3 times 2 or 2 times 3, the answer is the same. So you don't have to leave it in that order. How I normally tell my students, if you're first starting algebra and you're struggling with getting them right, order it. Alphabetical order and numbers at the front. So here, I would have wrote 2 times 3 times 4. See, all the numbers come first. Then I write the letters. A times A times B times B. Can you see what I'm doing? I'm just rearranging them. The reason why I do that is because it's clearer. You can times numbers. You do know what numbers are. That's what you've been doing since primary school. You're timesing numbers. So here, what's 2 times 3? 6, but then you times by 4. 24. Good. So this simplifies to 24. Then you look at the next bit. Times with A times A. A squared. Good. Not 2A. Okay, this is repeated multiplication, so it's A squared. Then you ask the same thing with this one. What's B times B? B squared, not 2B. Yeah, so this is B squared. See how I'm splitting it up? So I group the A's, I group the B's, and then I group the numbers. But remember, we're too lazy as mathematicians. We don't write the times. We just write it as 24A squared, B squared. See how it's one term? There's only one term. This one has 3. It's separated by a plus or minus sign. That's how you know. When there's plus or minus, it separates the terms. That's when you add them. Okay? Whereas when you have a lot of times, it all technically is just one big term. And your idea is to make it smaller. Instead of writing 2a times 3ab times 4b, it was easier to write 24a squared b squared. Okay? That's what you're training to do today. So this bit is today. Last session. One's addition, one's multiplication. Let's do another one. Flip over. Flip over the page. All right. Whoops. All right, so we did multiplication. Now we're doing division. Same idea. Let's do division. Now, division works in the exact same way, except it just looks scary because there's fractions in it. That's why last time you had to do fractions. So here, let's start off basic. What's 5 divided by 5? 1. A lot of students think 0. And I'll tell you why students think 0 after this. So that means if 5 divided by 5 is 1, then a divided by a must equal to? What's a divided by a? 1 as well. We just don't know what that number is. Yeah? So 5 divided by 5 is 1. 3 divided by 3 is 1. 1,000 divided by 1,000 is still 1. So of course a divided by a is 1. Okay? If you divide itself, it's always 1 because you fit in yourself once. Yeah? So The idea is if you divide by yourself or itself, it will always equal to 1, not 0. The reason why students think 0 is because those who have tutoring would have done something like this. With that question, this is how most teachers teach. They just do this. If there's an A on the top and A on the bottom, cross it off. Cross it off. You're left with an A, so the answer is A. Now, yes, you get the answer, but you're losing out on the actual understanding. What's truly happening here? Why does a constant disappear? Doesn't disappear. It actually is missing the fact that this is 1, 1. A times 1 times 1 gives you A. That's the actual logic to what it is. Okay? Or if you want to break it up even further, technically it's A times A times A. On the top, there's 3 of them. On the bottom, I've got A times A2. 2 A's on the bottom. What number goes here now? If I need 2 A's on the bottom, there's still missing something here. What number would go here that doesn't change the denominator? 1. 1's the only number that if you did A times 1, it's still A times A. So if you do it this way, can you see A divided by A divided by A? That's why it's 1 and 1. 1 times A, that's how you get the answer of A. Okay? So the reason why this is not normally taught is because a lot of students struggle with fractions. So when they see that, they check out already. So as I'm describing it, students are like, what is he doing? So many fractions. That's why they prefer that method. That's why a lot of teachers teach that way. And by the time they get to year 9, year 10, mistakes happen all over the place. So I give them something like x plus 1, x squared like that. And a lot of students will do this. They'll cross off the x, but you can't do that. This one you can't do. You can do it if it was x squared over x. Yes, you can do that. But because they don't have a full understanding of what's happening, they've just memorized mathematics. Mathematics is not just magic. It's actually logic. There is a reason to why things work. There's a black and white answer. There is no in between. It's just yes or no. So here, students make that mistake not because it's a mistake. It's because they learnt it wrong. So I try to teach you the right way, but it does require you have to have a foundation. Meaning your fractions, don't get intimidated, write it properly, question, method, answer. That's how you see the errors that a lot of students do. Okay? All right, team, so let's have a look at division now. So that means up here, when you write that as a fraction, you can actually split up fractions like you did back in last term. You see 5, you can write it as 5 over 5 times, again, you got another 5 over 5 times, and you got 1 5 over here in the numerator. 5 as a fraction is 5 over 1. That's why you can see it simplifies to 5 divided by 5 is 1. 5 divided by 5 again is 1. And then 5 over 1. So when you multiply it all together, it becomes 1 times 1 times 5 is 5. And then 5 times 5, 1 times 1 times 1 is 1. See that? That's why the answer is 5. That's how you get the answer of 5. Your teachers will teach it this way. Well, I'm your teacher this year, but generally you'll see teachers do that. Okay, so they'll do the cross off. So if there's 1 on the top, 1 on the bottom, and they cross it off, it's okay to do as a shortcut, but you have to understand why it works. And if it works, you can do shortcut. If you're doing it blindly, you'll eventually get to the point where I'm saying at 9, 10, 11, 12, you keep getting it wrong. Okay? All right, team. So let's practice now with division. So we know that when you have one top on the bottom, one top, one bottom, you can cancel it out to be 1, not 0. Cancel out to be 1. Here we go. Let's do an example. Let's do this one. Looks scary? Break it apart. Okay, so write down what you understand. 10AB. What does 10AB mean? Break it apart. What does 10AB mean? What's in between the A and the 10? And what's in between the A and the B? Times. So write it down. Yeah? So mathematics, just write it down. Don't try to do it all in your head. Write it out. 10 times A times B. It's a fraction. But when you're timesing, you can actually split up fractions. So that means on the bottom, you can write it as 15 times B times C. But remember, the order doesn't matter. The order doesn't matter, but I like the letters to be under the same letter groups to make it like your life easier. So instead, this is what I would do. We need one B on the bottom and we need one C on the bottom. So here's my B, but I need another C on the bottom. There's nothing wrong. See, that's 15 BC. I do have 15 BC on the bottom. And on the top, it's 10 times A times B. But I have these missing gaps. What goes in the missing gaps? 1. Logically, because 1 doesn't change it. 15 times 1 is still 15. And AB times 1 is still AB. So by putting a 1 there, can you see how I separate it out? And it's actually not that intimidating anymore. Because B divided by B, we already know. What's B divided by B? 1. Anything divided itself is 1. So this cancels out to be 1. And then anything can I cancel out? No, 1 divided by C, can't do it. A divided by 1, can't cancel it. But 10 and 15, you did that last term. Equivalent fractions. What number goes into 10 and 15? 5. So how many 5s in 10? 2. And how many 5s in 15? 3. So it becomes 2/3 times A over 1 times 1 times 1 over C. See how I'm just simplifying it? That's all I'm doing. So it looked intimidating to begin with, but when I break it all apart, you're really just working on little bits and pieces together. Now when you're doing multiplication of fractions, top with top, bottom with bottom. So here we go. 2 times A times 1 times 1. So what's 2 times A times 1 times 1? Take your time. What's 2 times A times 1 times 1? 2A. Because 2 times A, you did it before, just 2A. But if you times 1, it doesn't change anything. So the numerator is 2A. On the bottom, let's work the numbers. 3 times 1 times 1 times C. 3. 3C. Very good. So together you get 3C, and that's your answer. There is no any more complication. I just took away the times. So 2A, 3C. Now, that is how I want you to do it if you are struggling with fractions and algebra. If you're already confident, and you might have learned from a tutor, the other way is a top letter and a bottom letter. You can cancel it out. It's 1. So the B's cancel out. And then 10 and 15, you can do it from here. 2, 3. And then you get your answer as 2, 3C. Yeah, so that does work. I do know a lot of students do it that way. That's how most teachers teach. But I do it this way because no matter how complicated I give it to you, you'd still be able to do it. But for the other students, if I just switch up a couple of things, they'll get it wrong. Okay, so if I started adding things like this one, see that? Students who have a tutor or have done it in the past, they will still be able to get this answer by doing the crossing. But those who don't know how the crossing works will not know how to do this. But if you use my method, what I just explained to you, you can still do this one. So we break it apart. Let's do the same thing again. Read the top line. What does A cubed mean again? What's A cubed? Yeah, very good. A times A times A. So just write it out. So every time you're unsure, write it out. Whatever's in your head, put on paper. Because that's what maths is. It's training your problem solving. It's training you to think. So A cubed is A times A times A. Then what's B squared? What's B squared? B times B. Because you got 2 of them. Remember, difference between times and addition. Repeated multiplication becomes indices. Okay? And then you got the C over there. But remember, when you write it next to each other, it means times. So here I'm going to do times C. Beautiful. So I split it up. All I had was A times A times A times B times B times C. I haven't done anything. All I did was just read what we've taught. Then divide that by, do the same thing for the bottom now. Here we go. Let's read the bottom. You only got 1A there, so that's 1A. Times with, what's B squared mean again? B times B. So here we write it again. Times B times B times C cubed. What does C cubed mean? What's C cubed mean? Beautiful, Nick. C times C times C. You break that apart. Now, that looks scary, but what if you just kept all the A's, all the B's, and all the C's together? See, if you kept all the A's, that's just A over A, because you got 1 on the top, 1 on the bottom. Then you got 2 A's on the top. So then say, all right, times A times A. But there's nothing on the bottom there for the A's. So I fill it up with a 1. So here we go, fill it up with a 1. This here, this expression is exactly the same as the top. times, let's do it again, times, we do the same thing. There's 2 b's on the top, 2 b's on the bottom, so I write it out. B over b times b over b. 2 b's on the top, 2 b's on the bottom, same thing. Times, let's do it again. It's 1 c on the top, 3 c's on the bottom. So here we go. That's 1 c on the bottom times 1 c on the bottom times 3 c's on the bottom. What am I missing up here? Fill in with a 1. I know this feels tedious, but that's what I mean. Even when I give you really hard ones, you can still do it. It just means you have to take your time. Better layout, better thinking. Yeah, so I'm teaching you theory. I'm not teaching you how to do something and memorize it. I don't want you to be robots. I want you to be thinkers. I want you to be critical thinkers, like a problem solver, a puzzler, right? Person that solves puzzles. So here, if you break it all apart, we can see a divided by a, which we already knew was 1. This cancels out to be 1. This also, b divided by b is 1. B divided by b is 1. C divided by c is 1. So really, what's left? There's only a times a on the top times 1 times 1. So that doesn't change. It's a squared on the top. On the bottom, I only have 1 times 1 times c times c. So if you put it all together, a times a on the top, c times c on the bottom, that gives me a squared, c squared. So even if you haven't learned index laws, which I haven't taught you, some of you might have learnt it from year 7 or maybe your tutors. But if you hadn't, you can still do this question. Even if I put numbers in there, I could put 15 and 32 over there, and you'd still be able to do it by separating them. Yes, it does take longer. Over time, you don't have to do this, and you do the short method, as long as you're getting it right. Okay, so if you're getting it right and you're confident and your fractions are good, it's a good exercise to work with. All right? All right, team, I'm going to leave the last example for you to try. For those who want to have a go, I'll write up the solutions afterwards, but that's it for today. So you got multiplication, you got division. It's all about layout. The better your layout in algebra, the better you'll understand algebra. If you shortcut it, you'll get to a point where you're limited. So show you're working.